All right, we will continue with our discussion of the cardiovascular system and looking at the second topic here, which is blood grouping and blood typing. Hopefully you know your individual blood type. If you don't, you could simply ask your doctor the next time you have an appointment. Or maybe you'll take advanced A&P here on the Western campus and do your own blood typing. We do that activity in lab in advanced A&P. So, depending on what your blood type is, there's four different blood types, and also what's called the Rh factor, which we'll go into detail on. But for right now, let's take a look at this chart because it really helps to explain things. If you are type A blood, what that means is on your red blood cells is an antigen that we have identified as A antigen. So that means these are special markers on your red blood cells that are unique to type A blood. So type A blood has A antigen on the surface of the red blood cells. If you are type B blood, you have B antigen on the surface of your red blood cells. So these are determined genetically what types of antigens you have on your red blood cells. So it depends on what your mom and dad were, which determines what your blood type is and what antigens you have on your red blood cells. So these are just special, it's hard to explain specifically what an antigen is without going into a lot of immunity discussion, but just think of these as surface markers, surface proteins on the surface of our red blood cells. So B blood type has B antigen on the red blood cells, A blood type has A antigen on the red blood cells, and if you're blood type AB, you have both A and B antigens on your red blood cells. So this is in the solid part of our blood, the red blood cells, and there's these special markers on the surface. So if we were born with these, if these developed when our red blood cells developed as a newborn, then in the plasma we're not going to find antibodies to these antigens because antibodies are things that fight foreign antigen. So if we are born with these on our red blood cells, we will not have any antibodies to A or B antigen because that would clump our red blood cells up and attack the red blood cells and cause death. So in a person who has type AB blood, they have no antibodies in their plasma against the A and B antigen. Now let's look at a person with a B blood type. A B blood type has B antigen on their red blood cells. Therefore, their body is not going to make B antibodies in the plasma because that would attack the red blood cells of that person and that would cause death. So we don't form antibodies against things that are naturally us, things that we're born with. However, a person would form anti-A or antibodies against the A antigen because that is not what's on a B person's red blood cells. So antibodies against the A antigen are present in people with B blood type because they don't have A antigen on their red blood cells. Let's look at a person with type A blood. They have A antigen on their red blood cells, therefore they form antibodies against the other antigen, B, because that would be considered foreign. B is not on the red blood cells, therefore they're going to form antibodies against the B antigen. Then if you look at a person with type O blood means they don't have A antigen or B antigen on their red blood cells. These red blood cells are completely clear of the A and B antigen. So there are no antigens on the red blood cells of an O blood type. Therefore, they will form antibodies against both A and B because it's not considered self. So think of whatever type of antigen is on the red blood cell as considered self, and the body will not form antibodies against self antigens. So again, type AB person would not form antigens against A or B because that's considered self. They were born with that on their red blood cells. B antigen on a person with B blood type, they are going to form A antibodies because that is not recognized. They only have B on their red blood cells. Type A blood type has A antigen, therefore they will not recognize B. That'll be considered foreign, so they will form B antibodies. And a person with O blood type has no A or B antigen, so therefore their body will consider A and B antigens as foreign, and they're going to form antibodies against both. So when did this become a concern? Well, it becomes a concern when we want to donate blood from one individual to another. So we have a little game here. Whoop. If I can access it here, I think this is the way we go. This is called the blood typing game, I believe. This is the blood typing game. I'll put it in here and whoop.
In order to determine blood type, we will visually centrifuge.
This explains the concept of blood type, so we'll just watch this here and get a better understanding of blood type.
These blood samples to separate the blood components. The ABO blood group is based on the presence or absence of two major proteins in red blood cell membranes, agglutinogen A and agglutinogen B. A person can have A and B, or neither A nor B in his or her blood cell membrane. These blood types are referred to as A, B, AB, and O. If a person has type A blood, his or her blood will contain antibodies against agglutinogen B. These antibodies are called agglutinins. Conversely, a type B person will have agglutinins against agglutinogen A. Blood compatibility can be predicted by understanding the differences between the donor and recipient blood types. The donor's blood generally only contains red blood cells with no plasma. Therefore, it is agglutinins in the recipient's blood plasma that determine if the donor's blood will be compatible. For these reasons, type O is known as the universal donor, while type AB is known as the universal recipient.
So, if we look at a worksheet that I posted on Blackboard under the participation assignments, you'll find a worksheet. I'll go into our Blackboard site here and find it. So in the Blackboard, on the far left side, you see participation assignments. I'm going to open up the cardiovascular worksheet here. I recommend printing this off and labeling it, but we have this page here that has the different blood types. So if we're looking at blood type A, what antigens would we expect to see on the red blood cells of a person with blood type A? Look at the chart below and we can see if it's blood type A, there's A antigen on the red blood cells. So you're going to put A here. What type of antibodies would we expect to see in the plasma of this person? Look here, if it's blood type A, they're going to have antibodies against antigen B. So you would write anti-B. Who can they donate to? Well, when we donate our blood, we're donating this top row. We're donating the red blood cells. So you don't want to donate a red blood cell that has an antigen on it that would match the recipient's antibodies. For example, I wouldn't want to give type A blood to a person with type B blood because in the plasma of that recipient are A antibodies that are going to attack and clump the A red blood cells. So who can type A donate to? Type A could donate to another type A blood type, or if we look at our antibodies here in our donor or in our recipient, type AB could receive blood from a type A person because a type AB person has A on their red blood cells, so they would not form antibodies against it because A is considered a self-antigen and so is B. They were born with these. So they're not going to form antibodies to either A or B. Therefore, we call these guys the universal recipient because they have no antibodies that are going to react with donated red blood cells. So here we would say type A and type AB. Who can they receive from? Well, if you look at the types of red blood cells they can receive, they could definitely receive type O because they're not going to form any antibodies to anything on these clean red blood cells. And then type A because a type A blood type only has B antibodies, and that's not going to disturb those A antigens. So for type B, the antigens on the red blood cells we can see are B antigens, so therefore they're going to only form antibodies against A because that would not be considered self. And who can they donate to? Well, they can donate to themselves, they can donate to another type B blood type, or they could donate to type AB because there's no antibodies in type AB recipients. So who can they receive from? They can receive from, again, type O because those red blood cells are clean, and they could receive from their similar blood type, which is type B. Type AB, antigens on the red blood cells would be A and B. Antibodies, no antibodies because they have A and B on their red blood cells, so neither of those are considered foreign, so they will not have any antibodies, so none. Who can they donate to? Well, they can only donate to type AB blood. Anybody else has antibodies in their plasma that's going to react with those A or B antigens, so they can only donate to other AB blood types. Who can they receive from? They can receive from anybody because they have no antibodies to react to any of these red blood cells, so they are called a universal recipient. They can receive from anybody. Antigens on the red blood cells of a type O, here we can see there's none. Agglutinogens, that's the same thing as antigens. So when you see that word, it means the same thing as antigens. So type O has no antigens on the red blood cells. Antibodies, because it doesn't have any antigens, it considers any of those foreign because they weren't born with any. So A and B antibodies will form in the plasma. Who can they donate to? They can donate to any blood type, because they have clean red blood cells that are not going to react with antibodies. And who can they receive from? Well, if we look at their plasma, we can see they have A and B antibodies, so they're going to attack any red blood cell with A or B antibody or antigen on it. So they can only receive from type O blood. So be sure you review this chart, rewatch the video, slow things down a little bit if you need to, so you really understand the difference between antigens and antibodies. Remember, when we're donating, we worry about what the antigens on the red blood cells are, because when we give people blood, it's usually packed red blood cells we're giving them, so we care about what antigens are on those red blood cells. And in the recipient of that blood, we want to see what kind of antibodies would we expect in that recipient based on their own individual blood type. So if our recipient is type A, we know they have B antibodies. If our recipient is type B, they have A antibodies. And if they're type O, they have A and B antibodies. So we really want to be careful we don't give red blood cells that are going to react with the antibodies of our recipient and cause massive clumping and death. So then that leads us to the second part of blood typing, which is being positive or negative. People can be A positive or B positive, or A negative, B positive, B negative, O positive, O negative. If a person is O positive, what that simply means is that they have another antigen on their red blood cells which represents the Rh factor. So we use the letter D to represent the Rh factor, so it's like a D antigen. So if someone is A positive, it means they have A antigen on their red blood cells and the D antigen, which represents the Rh factor. So that means they will not have antibodies against Rh factor in their plasma. This only really becomes an issue when we have a mother who is Rh negative, which means she will form antibodies against Rh factor, but she has a baby who is Rh positive. Because when baby and mother's blood may mix during childbirth or late in pregnancy, that can cause the mother to form antibodies against her baby's red blood cells, and that can cause massive clumping and death in the newborn. So it's very important that we know the blood type of the mother. Any mother who is Rh negative is going to receive a special shot called RhoGAM to prevent her from forming antibodies against her baby's red blood cells. So if a person is B negative, AB negative, A negative, O negative, and becomes pregnant, then and there's a possibility that baby is positive, which we always will treat regardless, because if we know the mother is negative, she has the potential to form antibodies that could harm the baby. We're going to give that mother a RhoGAM shot. So if a person is O negative in terms of their blood type, that is the best donor to be, because they do not have any antigens on their red blood cells. They're negative for Rh factor, and they do not have the A or B antigen on their red blood cells. So when we donate that to someone, there is nothing for that recipient to react to, because there's nothing on those red blood cells. So O negative is a very rare blood type. It's only about 1% of the population, but they can donate to most people. So it's really a good blood to have on ambulances, and for people that are going to an accident scene and they don't have time to blood type that victim or patient, they can just give them O negative safely, because there's nothing on those clean red blood cells for that patient to react to. So this is just a slide that describes how we type blood. Like, if you don't know what your blood type is, what you'll do is you'll put a drop of blood on a slide, and then you'll add we have a little bottle of antibody A and antibody B. If it clumps when you add A antibody, you know that you are A blood type. If it also clumped with when you added B antibody, you know you have B antigen on your red blood cells as well, so you're probably AB blood. Here, a type B blood person, when we add antibodies to their blood, if we see clumping when we add antibody B, we know that it reacted with the red blood cells on that patient's, or on your blood. So we do this in the lab when we want to type a person's blood, but this does not represent when we donate blood. We certainly don't want to see clumping when we donate blood. We do not want an antibody-antigen reaction. So to practice with this, you can play this blood typing game. It's a lot of fun. Tests your understanding and does some more reteaching if you're not doing very well, but it's a fun game, and I highly recommend that you play it, because it'll get you motivated to see if you know your blood typing, and adds a little humor to it as well. So that concludes our discussion of Part 2 of the cardiovascular system on blood typing. Be sure that you complete that worksheet and go through it, make sure you understand it, and try the blood typing game.